Quickly in this video, I want to comment on how we could use the properties of rational exponents to simplify expressions like the ones you see I've written here. But basically, you notice I use rational exponents as kind of my basis for doing this. If we were to rewrite these as rational exponent, we say this is 4 to the first power, cube root of that, 16 to the first power, cube root of that. I suppose we could interpret this as 4 to the 1/3 power times 16 to the 1/3 power. And what I want to kind of highlight here is this. These don't have the same basis, but they do have the same exponent. So if we wanted to pull some algebraic sleight of hand here, one of the properties of exponents says this: if you were to have a product of two things to the power of something, you would actually have to distribute this through. So what we've done is we've worked backwards, and we said that this is really 4 times 16, which is 64 to the 1/3, which we could say is also the cube root of 64. So this very long argument that I provided here using rational exponents, what I could basically have said was this: when you multiply two roots that have the same indices, so we say the nth root of a times the nth root of b, we should write this: it's always equal to the nth root of a times b, and you can combine the stuff that's on the inside, which, by the way, the cube root of 64 this is actually a perfect cube. We say, well, what could I take times itself 3 times and get 64? And the answer would be a positive 4, just a positive 4. Okay, so let's try this again with this expression over here. And what this is doing, this was our product property, and I guess we'd want to set that aside here. This is important enough that I want to write this. So we say the nth root of a times the nth root of b is the nth root of a times b. And this works both ways. You can split roots up as well as you can put them back together. But we say this is very true also. The nth root of a over the nth root of b would be the same thing as, in general, the nth root of abs. Okay, so you can split this radical up top and bottom of a fraction as well. And that's important here because we say it's the fourth root of 162 over 2, which is really the fourth root, if we want to, of 162 halves, which is the same thing as the fourth root of 81. And actually, I could say, well, could you think of any numbers that multiply times themselves 4 times and give you 81? And this is actually a perfect fourth. We say it's 3. And because it was a fourth root, that's an even thing, we get plus or minus 3 for our solutions here. But that's how you use the properties of exponents to simplify expressions with radicals like that. Cheers.